Welcome back to Daily Stand-Up. Today we're going to be covering a system design cheat sheet. And basically this is going to be a collection of terms that you'll probably see pop up in a system design interview, a system design book, an article, a blog, whatever it is. You'll see a lot of these terms pop up. And my goal with this is that I want to categorize them by core topic, but also just provide you a resource that you can check to see if you know most of these words, right? You're not going to always see these pop up, but you'll see a lot of the principles and topics pop up. So I was hoping to just have this resource available for you to get a gauge for yourself moving into 2025. So I have these categorized by topic. This is not exhaustive, but it covers what I feel like to be a lot and a lot of the core ideas. So I want to start with cache. Cache is for sure one that's going to pop up everywhere. And cache is basically just the idea of just an object store. So caching is talked about in the context of Redis. You'll hear AWS Elastic Cache. You'll hear the word data partitioning pop up, also called sharding. I prefer to call it data partitioning because I feel like that's more in tune to what it just makes more sense. Data partitioning is this idea that basically if you have three nodes on your, let's say your Redis cluster, you have node 1, 2, 3. If you're always writing your cache objects to node 1, you're gonna create a hot node. Basically, that means that all the traffic is going to be spiking to node 1, and there's going to be very little or no traffic to node 2 and 3. So to get around this, there's been a lot of strategies around how we make the keys, because the cache is just a key value store, right? So this idea that we have to create a key naming strategy is very important. So people have done hashing implementations. One common one you'll see come up is using the modulo function to create your hash value to more evenly disperse your data across all the nodes. So you can look that up, but there's a number of different strategies to avoid creating just, a hot node that has all the traffic going to it. Time to live value, basically just the expiration date. You can talk about it. So if it's 30 seconds time to live value, it'll expire. That object will expire after 30 seconds. If it has rolling expiration, it'll expire after the last cache hit. And cache hit is when that object is retrieved. Cache miss is when you check cache to see if that object exists. And if it doesn't, then that's a cache miss. You'll hear caching in the context of in-memory cache, basically on the on the browser, for example, is of one, versus a distributed cache, which is saved to, let's say, some form of cloud storage. So in-memory cache, you'll hear, like there's one called memcache. You'll hear browser cache. There's a number of different ones. Distributed cache is like more of like your Redis cluster on AWS Elastic Cache. But you'll hear those terms thrown out. I want to move down next to replication. Replication is this idea of basically replicating, let's say, your one database instance across multiple instances or nodes. You can hear this in the context of RabbitMQ if you have a replication, if you have a replicated cluster set up, so you have multiple RabbitMQ nodes running. Replication could be talked about in the context of ring replication, parent-child replication, or leader-follower replication, and also in the context of read-write replicas, most commonly used in the context of databases to better serve traffic, more evenly dispersed traffic. You're gonna find out a lot of principles is just, how do we take traffic and disperse it across, evenly across multiple nodes, right? It's no different than driving in traffic on the highway, right? There's one lane is going to be less congested, hopefully, than, maybe 3 or 4 lanes. Maybe not, but that's like kind of the idea. And so you can think about like ring replication as like a roundabout. You can think about parent-child replication as kind of like your almost you can think about that almost as like a four-way stop, kind of, but maybe not. Front end is just kind of what it sounds like. Front end is basically everything that the user interacts with. So it's like you'll hear words thrown out like client, DNS, which is domain name system, HTTP sessions, which in the .NET world, which is what we do on this channel, is .NET session ID, which is just a header value that's attached to the request response to keep track of the user's interaction with your system throughout the request response lifecycle. So the front end is the client distinct. Oh, it's the front end is the client processing. It's not the server. So the front end is often associated with, your React app, your Angular application. It's all the browser side, the client processing that happens away from the server or the back end. Front end is, you'll see, we often talk about decoupling the front end away from the back end, making the front end its own service that can be scaled independently from the back end. It's hard to capture everything that goes into front end, but we'll get into more terms that I think also tie into front end soon. So the back end is all the server side code, the server side web services, the API gateways, the load balancers, the instances. It's your APIs, whether that's REST or SOAP APIs, or gRPC or GraphQL. It's your web services, your background services, your logging, your exception handling, rate limiting, and monolith versus microservices. So there's so many terms that go into backend. It would be impossible to cover everything in this video, but there are a lot of terms there that you can look at and just to get a gauge for yourself. But one thing I want to call out specifically is instances. So again, with replication, you can have multiple instances of a running service. So you can have service A and service B of the same basically service, but running on multiple nodes or running on multiple instances. So that we touch now on the idea of scalability. So how do we scale our back end? There's so much that goes into it, but this is just a starting point. Databases you can talk about in the context of relational, NoSQL, this idea of cardinality, indexes, primary and foreign keys. You have more keys than that, like composite keys, but there's more to that as well. Distributed locks, sharding, and migrations. So migrations is this idea of how do we update our database or keep our database up to date. So one example of this is in .NET, we can set up migrations to run whenever our service starts up. So it'll basically look at the database. If it detects a new migration, so it'll look at this actually table within the database to see, okay, when is the last time a migration run, or when is the last time the database has been updated? If we detect that we have a new migration file in our code, we'll run that and it'll run whatever code we have in there. Let's say we're adding a new table or we're altering a table, it'll run that, update the database, and then our application will continue to resume. So it's a part in the middleware that'll keep our database up to date. You can do this with LINQ, you can do this with just a file that gets executed with a script. You can do this with a lot of different things, but it's a very, very good way to keep your database up to date without having to have any real manual intervention, but it also helps for rollbacks as well. So it'll always keep your database in the right state. Again, we have this idea of sharding here. Distributed locks really is going to be talked about in the context of distributed computing. So if you have two nodes of one web service, and node 1 tries to write to the database, and node 2 is trying to retrieve or get from that database, and they're trying to get the same row, this idea of distributed locking will basically place a lock on that row. So if node 2 tries to get that, it'll see, hey, node 1 has a lock on it, you have to wait. So distributed locking is you can get very in the weeds about that. You can read entire books, research papers just covering that topic, because it's still it's still like an open problem that exists. You'll see a lot of different strategies to avoid deadlocks and different ways to get around this idea of distributed locking. Keys, indexes. Basically, indexes are hashes of the table that basically group your rows into groupings. So if you try to do a select, it'll look at the hashes instead of every single row. So indexes gets complicated, but it's better to index on high cardinality fields rather than low cardinality fields, because high cardinality fields, it'll get you more hash groupings. Low cardinality will result in basically very few, which really doesn't provide you an efficient index. Relational and NoSQL. So again, you'll hear NoSQL also used in the context of document store. You'll hear NoSQL with trying to think of how to cover that, but you'll hear those terms come up. So it's better to get familiar with those and just really just be able to make a determination of when you would use NoSQL versus when you would use relational. The next one is a larger topic, and I put this under the topic of asynchronous. So immediately we're going to be talking about queues, because queues allow for more of this approach to event-driven design. We've covered RabbitMQ very in depth on this channel. RabbitMQ is a message broker that implements the AMQ protocol, and that queues allow for service A to publish a message without having to wait on service B to consume the message. So it allows for this asynchronous data flow. And queues are always going to be used in the context of how do we scale the system, create greater scalability. You see publisher, consumer, you have event-driven design. Event-driven design is very popular right now because it allows for this asynchronous data flow, and it allows for greater scalability because you don't have to wait on the traditional request response. So you avoid creating a bottleneck when service A attempts to communicate with service B. You'll hear, again, RabbitMQ, you'll hear Kafka, so you may hear the word topics. Orchestration, choreography, sagas, which is just basically a distributed transaction that involves multiple services and multiple either queues or topics. Retry policies, again, we've covered retry policies very in depth on the channel and why they're important. But you'll hear so many of these terms, but basically a lot of them really boil down to this idea of event-driven design and using queues effectively within your system. So there's so much here. There's so many large topics here, but this is, I think, a good starting point for just covering the broad topic of asynchronous data flow, and it's a large topic. Cloud is equally as large of a topic, and you'll hear AWS, Azure, serverless, which an example of that is Lambda functions in AWS. You'll hear S3 buckets. You'll hear EC2. You'll hear Elastic Cache. You'll hear just so many words, but I can't even list them all because I think at some point you're either going to have to pick AWS or Azure and then get a book and then read through and just get familiar with a lot of the cloud service offerings. But this is just, I had to include cloud because you have to. And for me, I chose AWS to learn. And so I got an AWS book to basically read through. And I think that's really the only way to study cloud and get familiar with all the terms. So I don't even know how to cover all the cloud terms, but cloud is going to be talked about a lot in terms of how you deploy things. What do you do, like if you're choosing to deploy on premise versus on the cloud, and just being able to recognize when it is appropriate to use a serverless function. And there's so much there, but an important implication with cloud is the cost. Cloud is expensive, and so being able to recognize when it is appropriate to use cloud versus not is important, and cost is a big consideration. So if you can bring cost into the discussion, I think it's important. Authentication is equally as important. So you'll hear the you'll hear the protocol OAuth 2.0. You'll hear authorization. You'll hear authentication. So just being able to make the distinction between what authorization means versus what authentication means. Roles, cookies, JWT, JSON Web Token. You'll hear single sign-on, SSO, tokens, redirect URLs, scopes. So token, redirect URL, and scope is used in the context of OAuth 2 because basically you're directed out to your provider. You give it a redirect URL once you have your token that will come back to basically whatever page you decide is on your application. The scope is basically what your user essentially has access to. And there's so much there, and I think I found it helpful to look up visual diagrams explaining what OAuth is and how it works. You can also look up OAuth versus OAuth 2.0, and there's a lot here. You can look up authentication providers, but this I feel like is a decent start to your journey learning about authentication. The next one is deployment. So deployment, you'll hear terms like instance size, on-premise versus cloud, EC2, which is an AWS instance you can deploy on, Docker, containerization, monitoring, alerting, auto-scaling. So auto-scaling is this idea of horizontal scaling. So if it detects that, hey, node 1 is experiencing high traffic, you can put it in an auto-scaling group to basically scale that out to more nodes. You can do this in AWS. You can do this in a number of places. Monitoring and alerting is a big one. So you need some kind of like monitoring system, like, for example, CloudWatch and Cloud Alerts in AWS that can detect if there's a spike in traffic and basically send a message to create a chain of events to happen. Containerization is a big one. Docker, I feel like just being familiar with Docker files, and how to deploy Docker images. EC2, and yeah, there's a lot there, but I feel like that's a good start for terms for deployment. The last one is I thought about grouping this in cache as well, but I feel like it's distinct enough from cache that it can kind of warrants its own thing. Is HTTP caches. So you have browser caches, CDNs, which is content delivery networks, caching proxies, and reverse proxies. You'll probably see reverse proxies pop up at least once. Basically, it'll say, okay, if it's a cache, it'll reach out to this proxy basically, or this server really. And if it detects that, okay, we have a cache hit, it'll just reverse it back to the client. If it detects if we have a cache miss, it'll reach out to whatever it needs to do to get that data. But you'll see that pop up, reverse proxies. You'll see CDNs be used in the context of a type of HTTP cache. You'll see a lot of headers be used. You can set no cache headers on your requests. There's a lot here, but you'll definitely see, I feel like, some form of proxy pop up. And so these are the type of HTTP caches you may encounter. So hopefully this makes sense. There's a lot of terms here grouped. Hopefully you can either pause and just kind of get a feel for where you are at with a lot of these terms. Again, this is not exhaustive by any means, but I feel like it's a good start moving into 2025. And so on this channel, we've done a number of kind of walkthroughs about systems. This is one that we did a while ago where I had a problem that we proposed and we worked through it on the channel. So we had a problem, we have the desired state, and we created this kind of mock system where we have a front end, back end, we have 3 queues. We have this queue processor system or service, and we have a database that's in an auto scaling group. So stuff like this is kind of what we do on this channel. partially is kind of work through system design problems and use a lot of these terms and then create mock systems. But we've also, as part of the system design series as well, we've done the code for creating some of this, and we have very in-depth RabbitMQ videos on this channel. We have retry policies. We've covered um, publishers, consumers, back-end technologies with .NET, front-end technologies with React. So we've covered a lot in this channel. But this is like just to put a lot of these terms in the context of what you may, be expected to draw or diagram would be kind of something like this, right? Just being able to piece these terms into an actual system, and just being familiar with how everything kind of would flow. So anyway, yeah, that's really all I had for today's video. So hopefully this kind of cheat sheet makes sense. And yeah, I will see you on the next one.